Okay, we're back. And we are continuing on our journey of solving logarithmic equations with logarithm expressions or logarithmic expressions on both sides. We had determined in the last step that the bases must be alike in order to proceed. Okay, so once you've determined, here's Rex number 4, remote example, all right? Log base 2, log base 2, these are absolutely the same bases, so we may continue. Once you do that, you can almost eliminate them from your sight and focus on the blocks. So x squared minus 4 is equal to 3x. Right? Well, you can tell right now we've got a quadratic. So we're going to set it equal to 0. All right? So we're going to move 3x over, put him in the middle. That's our linear term. X squared minus 3x minus 4 equals 0. Okay, we know we have to factor this. We have a lead coefficient of positive 1, so I can just make the houses. Okay, and we know the signs are going to be different. Okay, so one of each. And two factors of 4 that differ by 3. Well, obviously, I'm going to put my x there. That's going to be 4 times 1. 4 times 1. That differs by 3, and 4 times 1 is 4. So I need a negative 3, so 4 goes with the negative sign, and 1 goes in here. Okay, now we're going to solve. Well, in this case, that's going to give me x equals negative 1, and this is going to give me x equals 4. All right, so we must check and see if either of them works, or none of them works, or both of them works. Okay, so if we check it, and I'll put that on the next page. Let me write my expression. All right, so let's check negative 1. All right, check negative 1. We're going to say, okay, log base 2 of negative 1 squared minus 4. And we're saying, is that equal to log base 2 of 3 times negative 1? All right, all I'm doing is I'm inserting negative 1 here and negative 1 there in place of x. Okay, so this is going to give me log base 2. Negative 1 squared is 1. Right? So that's going to be 1 minus 4 equal to log base 2 of negative 3. All right? Now, that's a problem. Okay? You're going to say, one might say, okay, Ms. Smith, it balances. You have the same block on both sides, but guess what? You can't have a negative block, right? So he's a negative block. So no to this. Okay? No to this. So no negative blocks. Remember, your block has to be greater than 0. No negative blocks. Okay, so negative 1 is out. This is an extraneous solution. Okay, it said, oh, I'm a solution, but it's not really, and we just proved it because it gave us a bad block. Okay, and blocks have to be greater than 0. All right, so I'm going to go to the next page, and we're going to check our other solution. Our other solution was 4. And we're going to plug it in, and we're going to see what happens. Okay, so we have our situation, our expression log base 2. So we're checking 4. Log base 2, 4 squared minus 4, question mark, equal to log base 2 of 3 times 4. All right, so we're checking. So log base 2, well, that's going to give me 16 minus 4. And then we're going to say log base 2 is going to give me 12. Well, 16 minus 4 is positive 12, so log base 2 of 12 equal to log base 2 of 12. Yes, so 12 is our only solution, okay, because it worked. It balanced both sides, and it gave us a positive or a non-zero block. Positive non-zero, okay? So that was a quadratic, but again, you can see the importance of having to check your answers. All right, let's move on to another example. All right, we're going to solve this. This is your Rex number 5. Rex number 5, solving logarithmic equations with logs on both sides. Okay, so we have checked the bases are the same, right? So you know we can proceed and we can set the blocks equal to each other. X squared minus 15 equal to 2x. Okay, quadratic again. Put our linear term in the middle, set it equal to 0. X squared minus 2x minus 15 equal to 0. All right, lead coefficient of positive 1 means we can do this. The signs are going to be different because it's a minus here, so 1 plus and 1 minus. X and x as we factor it. Two factors of 15 that differ, because these are different signs, by 3. Well, obviously that's going to be, by 2. That's the number. Okay, so 5 times 3. All right, I want a negative 2, so 5 has to be bigger and he has to be negative. All right, so that produces x equals negative 3, question mark, and x equals 5, question mark. We don't know, so we're going to check it. All right, you're going to get to where you can do this in your head pretty quickly by eyes. Okay, so let's check that. Let's just go ahead and put it in the blocks and see if our blocks come out to be the same, because we know the bases are the same. All right, so you can say, okay, x squared minus 15 is one of our blocks, equal to 2x. All right, we're going to test negative 3. All right, so I'm going to put negative 3 there, negative 3 there. So that's going to give me negative 3 squared minus 15. And you're like, okay, is that equal to 2 times negative 3? All right, well, you can see right here, that's going to be a problem, because that's going to be 9 minus 15, and that equals negative, oh my gosh, is that 6? Okay, this equals negative 6. So we have negative blocks. Well, you can't have negative blocks, remember? So that's a spoiler. So we know that negative 3 is out, because he produced two negative blocks. Your blocks cannot be 0 or negative. Let's test 5. I'm going to put him in here first. So 5 squared minus 15, and I'm just putting him into the blocks right now, 2 times 5. Okay, so I'm just substituting this guy in here and in here, and these are just my blocks. All I did is I removed my blocks from the green statement and just brought them down here. So that's going to be 25 minus 15, and that's going to be 10, and yes, 10 equals 10. So we win on both counts. The blocks are both non-zero positives, and they balance on both sides. So the only solution that we have for this Rex number 5 is 5. Okay, this was an extraneous solution. No, negative 3 was extraneous, 5 was the real deal. Okay, so this is the name of the game when you're doing these. All right, pause a second. Okay, next skill, same chapter, right? Chapter 7.4. Now we're moving on from equations and we're going to start solving inequalities. Okay, with same base logs on both sides. Okay, but instead of an equal sign, you're going to have an inequality. Remember, your blocks must be greater than 0. So you have to look at your solutions, and you're going to have intervals here, so you're going to have to put in interval notation. All right, so blocks must be greater than 0, so keep this in mind when writing solutions in interval notation, okay, in these inequalities. All right, so you just have to be careful with these. All right, for example, log base b of block A is less than, or could be less than or equal to, log base b of block B. The bases have to be the same, just like we did before. But instead of an equal sign, we have an inequality. Then what you're going to have is you're going to have your block A less than or equal to your block B. Okay, it's the same thing we did with equal equations when we had an equal sign here. Now we've got inequalities. Okay, the same goes for greater than and greater than or equal to. So remember, your answers are going to be in interval notation. All right, they have to be. And remember, your blocks have a limit on how low the numbers can go because they can't go below 0. Okay, so what we have to do at the beginning is we have to figure out, okay, what can my blocks not be? All right, so let's take a look at Rex number 6. Okay, I may have to split this video too. It's a lot of information, okay? So don't sweat it. All right, solve log base 3 x greater than 4. Okay, interval notation is what our answer is. Okay, well this one, all right, all you recognize is it's in log form. You can't do much here. We've got to solve for x, so you have to isolate him. Well, you're going to have to break him out of logarithmic form and put him in exponent form. So remember how we do that? We get rid of the word log, that releases this base. He goes over and he bumps up Mr. Exponent. So now you say x is greater than or equal to 3 to the 4th power. Okay, so we didn't have any flippage, we didn't have anything weird going on. We just said, okay, 3 to the 4th power. Well, x has to be greater than 81. All right, in interval notation, since x was our block and we weren't doing anything to it, you can simply say 81 to infinity. Okay, it's not including 81 because there's no equal under there, so that's why it's parentheses. Anything greater than 81, not including, is going to satisfy this inequality. Okay, that was Rex number 6, and it was very basic. All right, I'm going to stop the video and start part 3.